Welcome to this lesson on Kubernetes architecture. I'm going to be talking in depth about the Kubernetes architecture. I'll also highlight some of the important challenges that we face as far as the application development is concerned, and the future as well, where we're heading. And additionally, I'll also talk about the Google infrastructure, the replication controllers, the container engine, and so on. So the role of containers is very important. We're now moving away from the standard hardware to scalable infrastructure. Virtual machines rather have a shorter life cycle. On the other hand, you can create a container just for a few seconds, and that's the power of serverless computing. And the future seems to be moving towards containers using Docker technology and so forth. So, Conway's law. It states that organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. In other words, simply put, organizational bottlenecks become code bottlenecks. So you got to keep that in mind. Here are some challenges. And solutions as well. So with microservices, things are pretty dynamic, with several moving parts, such as containers, right? They come and go. You can package things into containers, you can ship them, and so forth. But you need additional automation as well. So to manage the entire containerization, for example, you'll have millions of containers, right? Google, for instance, creates 2 billion containers per week. Well, how do they manage it? They need to have an infrastructure capable to manage all of this activity. And of course, monitoring is also a challenge. So we need systems that dynamically can discover and track, create logs, and be able to tell us greater details about what's going on. So we need to find efficient infrastructure, and that, as an example, is Kubernetes. What this does is simply manages the entire infrastructure. It takes all these container images sent from Docker, puts them into pods, and then creates these replication controllers and manages the infrastructure, and also can automate the entire infrastructure for you. So it scales automatically. And that's exactly what I mean by infrastructure management. Okay, so you need to have an efficient infrastructure management in place so that you can overcome some of these challenges. And I've also talked about solutions at the same time. So, what is Kubernetes one more time? It's an open source system for automating deployment, scaling, and management of containerized applications. It groups containers that make up an application into logical units for easy management and discovery. It's an open source orchestration and provides broad industry support. And it supports multi-cloud, on-premise, VM, bare metal, and whatnot. Few words, definitions on the elements of Kubernetes. So a container is simply a sealed application package that contains its dependencies, code, and everything else. Pod is simply a small group of tightly coupled containers. Labels are simply identifying metadata attached objects. Selector is a query against labels, producing a set of results. A controller is a reconciliation loop that drives current state towards the desired state. And service is a set of pods that work together. So we've covered this before. Just wanted to highlight this before I get into the architecture. All right, so things that are involved in the Kubernetes architecture. And we'll take a look at each one of these in detail. So we have the Kubernetes master. It works on a master-slave architecture, by the way. So the master is the main controlling unit of the Kubernetes cluster. It runs multiple components to manage the cluster-wide workload and directs communication across the system. etcd, rather, is a data source. It is deployed as a cluster to avoid a single point of failure and ensure high availability, right? So like fault tolerance. Configuration representing the overall state of the cluster at any point of time is also stored in the etcd. And then we have the API server component as part of the architecture, which implements a RESTful interface and is used by user to configure workloads and containers across nodes. The APIs enable integration with different tools and libraries. Next is the scheduler. It simply binds a pod to a node based on resource availability score on that node. And again, a pod is, recall, just a bunch of containers grouped into a single pod. So scheduler tracks resource utilization on each node and makes sure that workload is not scheduled in excess of the available resources. The controller is the means through which pods can scale horizontally across the cluster, and its primary task is to maintain desired number of replicas at any point of time. All right, Kubernetes minions or nodes, right? Nodes are also referred to as minions. So if you see this word, that means a node. In Kubernetes, the server where it contains workloads. In Kubernetes, the server where containers or workloads are deployed is called the worker node. And minions run components that are required to communicate with the master and configure networking for these containers. The kubelet is responsible for what's running on an individual node itself. So it can be thought of as a process supervisor, but is really more focused on running these containers. It has one job, given a set of containers to run, make sure that they're all up and running. And a few last terms regarding the architecture of Kubernetes is the kube proxy, which lives on each and every node of Kubernetes and routes destined traffic from the service IP and port to the appropriate backend container. Kubernetes also has a built-in load balancer, which it refers to as a service. The proxy service then assigns a random port for the newly created service and creates a load balancer that listens on that port. And this port, of course, is configurable to listen to an external port, such as port 80, for example. The cAdvisor is an agent that monitors and gathers information on container resources usage and performance. It collects container stats such as CPU, memory, file system, network usage, and provides an overall machine usage and performance statistics by analyzing the top-level node. All right, putting things into perspective, right? So this is what the entire Kubernetes architecture is made up of. So we have the etcd, the storage. We have the API server that talks to the kubelet, scheduler, controller manager, and the kubelet uses the service proxy. They're bundled together. The kubectl is the actual command that we use when we work with shell, and I'll demonstrate this in subsequent lessons. When you open up the Cloud Shell, you use kubectl command to execute Kubernetes commands. All right, Kubernetes labels. Again, these are just attaching information, metadata information to the front end, production, testing, back end, and so on. So these are just labels, right, to organize ourselves. We can automate cluster deployments, and this is again moving into the Google Cloud environment, right? Because within the Google Cloud, Kubernetes is really the hosted service or engine built into Google Cloud, okay? You don't really get to see in the Google Cloud area, there's no option where it says Kubernetes, right? But I'll show you how that's managed and how to in fact open up the Kubernetes UI through the shell. So we can automate cluster deployments. We can configure a cluster. There are templates in Google Cloud Platform that you can use, and deployment can be on any cloud virtual. End user is configurable, and you can manage fully by your IT department. The configured components include the master, nodes, pods, containers, and of course your external services such as DNS and so forth. The replication controller is another concept we just talked about. Simply makes sure that everything is replicated, right? So all these containers and pods, if one container goes down, the next one kicks in, okay? So it keeps replicas of these containers. The Google Container Engine within the cloud platform is wonderful. It basically runs and manages and optimizes the cluster itself. So the APIs and tools within the Google Container Engine perform all of these operations. And the container engine is provisioned or can provision cluster in a matter of seconds. So you can create a cluster within no time. And it's an optimized or fully optimized cluster environment. And this container engine is where Kubernetes actually runs. Okay. Again, you don't get to see an option where it says click on Kubernetes or there's a menu. There's no such thing within the Google Container Engine. Of course, you can access through the kubectl command from the shell. But the Google Container Engine is actually where things are happening with Kubernetes. All right, so let me in fact demonstrate whatever we just talked about, right? So here I'm logged on to the Google Cloud Platform and I'm on my dashboard. Let me open up the gallery here, products and services. And under the compute section, you'll find the container engine. Okay, this is where Kubernetes resides. So when I click on the container engine, for example, it'll bring up the container clusters. So depending on the number of clusters I have, it will show up here. So right now there's one cluster running called Claydesk app. So if I click on this cluster, notice it will give me the detail, the master version, the endpoint, the size, and then the node zones and so on. The node pods are also listed in the bottom here, and it gives you the details about the machine itself. So again, no Kubernetes at this point in this area. It's only when you access the shell, for example, activate the Google Cloud Shell, and then you run the kubectl commands to get to your UI dashboard. And I'll demonstrate how that's done when we actually get to our lessons. But for right now, I just wanted to show you how you can actually work with clusters and where and how it looks like. Similarly, there are other things that you can take a look at, such as the compute engine, for instance, which gives you the VMs that you're running. So here are the VMs that we have created so far, and then you can work with this. So Google Cloud Platform is pretty powerful, and in this course, of course, I'm going to detail out everything they need to know about the Google Cloud engine, creating VMs, creating clusters, how to work with Kubernetes, and then building and working with different projects, right? So maybe a single project such as the WordPress website that will configure and deploy in one of the clusters, and I'll also demonstrate a multi-tier web application, how to create master slaves and nodes and so forth. So in conclusion, we talked about the containers one more time, the Conway's law. We also mentioned various challenges and solutions as well. And we took a look at in-depth about Kubernetes architecture, various elements that make part of the Kubernetes, and how to use the Google Cloud to automate cluster deployments, use templates, how do replication controllers work, and finally, the place where Kubernetes resides is the Google Container Engine. So I hope this helps. Take a look at some of these concepts, understand the terms. You'll hear them quite frequently throughout the course itself and otherwise as well. So with this, let's move to the next lesson.